Okay, let's take a look at how to balance chemical reactions. We are looking at slide 14 right now. We have aluminum plus chlorine gas gives us aluminum chloride. Okay, so this is solid aluminum, chlorine gas giving us solid aluminum chloride. Okay, we see that we have one aluminum, one aluminum. However, when we look at the chlorines, we have 2 here and we have 3 here. What I first try to do is make whatever number that I have odd, I try to make that even. And you do that, you never manipulate the subscripts. You don't do that, because if you change the subscripts, you change the composition, you change the compound completely. The way that we use to actually change how many chlorines there are is we manipulate by using molar coefficients in front of the whole molecule. However, when I change that, when I put different numbers here, integers for molar integers, that changes the whole molecule, not just the chlorine. So it will also change the aluminum. So you have to keep that in mind. But that's the first thing that I do, is whatever is an odd number, I try to make it even. How do I make this an even number? I multiply it by 2. Okay, so here's 2. Now I have on this side, I have 2 times 3. We always multiply it. 2 times 3 is 6 chlorines on this side and only 2 on this side. But it's easy to balance the chlorine on this side, because if I put something in front of the chlorine here, I don't change the aluminum necessarily. So I have 6 chlorines on this side, but only 2 on this side. To make this 6, all I have to do is put a 3 in front of that chlorine. Now 3 times 2 gives me 6. So my chlorine is balanced. And then lastly, I have 2 aluminums, but only 1 here. To make this 2, I put a 2 in front. Note that I don't put the 2 down here as a subscript, because that changes the molecule or the atom. I put that in front of the atom or molecule. So now this should be balanced. Another thing that I do once I make my odd numbers even, I always leave those elements that are by themselves last, because if I change the number in front of them, it doesn't affect anything else that I have balanced out. So they're the easiest ones to balance, because you can put any number in front of them and it's not going to change everything else. So I typically leave those for last. Let's look at the next example. We have magnesium solid plus oxygen. Anytime you hear oxygen gas, it's going to appear as a diatomic molecule, so 2 atoms of oxygen together, and it gives me magnesium oxide, and that's a solid. Okay, I have 1 magnesium on either side, which makes okay, I have the magnesiums balanced. However, when I look at the oxygens, I don't. I have 2 over here and 1 over here, which means I need to balance my oxygens. How do I do that? I cannot put a 2 here as a subscript, because then I change the molecule. Therefore, if I can't do it as a subscript, I have to put the 2 in front of my whole molecule. Now I have 2 oxygens, but I also change the number of magnesiums, because that's what happens when you put the coefficients in front of the whole molecule. It will change everything else. However, so my oxygens are now balanced, 2 here and 2 here. I change the magnesiums, 2 magnesiums here, only 1 here, but it's easy to fix, because all I have to do is put a 2 in front of this magnesium, and now everything is balanced. Let's look at the next example. I have aluminum oxide solid plus HCl, and that's aqueous, and it gives me aluminum chloride, solid, and it gives me water. Liquid. Okay, so once again, I look around and I think, okay, the easiest way for me to do, I start out with, let's say with the chlorines. I have an odd number here. To make that even, I can put a 2 in front of this molecule. And some of this is trial and error. You may write and then find, oh, this doesn't work, so you need to erase it, and that's fine. Just to systematically work through until you figure it out. Okay, now I made the aluminums equal. I have my chlorines here are 6, but here there's only 1 chlorine. So if I put a 6 here in front of that chlorine, I made 6 chlorines as well. How many hydrogens? I have 6 hydrogens over here, but only 2 hydrogens over here. To make this 6, I need to put a 3 in front of the molecule. I cannot stress this enough. Do not change the subscripts, because if I had put this here, it would not be H2O. It would not be water anymore. I changed the compound. So if I need to, when I balance chemical reactions, I only mess with the coefficients in front of the molecule. And now I balance my hydrogens. 3 hydrogens, or 3 times 2 is 6. 6 times 1, that's 6 here. And then lastly, I have to look at oxygen. 3 times 1 is 3. 3 over here, and I'm balanced. That was it. The one thing that I also want to mention is that we're looking for the lowest whole number ratios. So if I had 2 over here, 12 over here, 4 and 6, so if I had 6, 4, 12, and 2, that means that I would not have the lowest whole number ratios, because I could divide everything by 2 and reduce it even further. But the way it's written, I have 1, 6, 2, and 3. So I cannot reduce it any further. I cannot do any more because I have that 1 over here. And we don't use half. So we don't use half, we use full integers. Therefore, we look to find the smallest whole number ratio. And that is what we did here. Okay, so let's look at the next example. We have C2H2 plus O2 gives me CO2 plus H2O. Okay, so this is gas, and this is actually in a gaseous form too. Gas, and this will be liquid. Okay. Now, where do I start? Well, we can start by the carbon. We have 2 carbons over here, but only 1 over here. So I can put a 2. And remember, I only use the molar coefficients. I do not mess with the subscripts. I have 2 carbons here, 2 carbons here. Now, I have 2 hydrogens over here, and I have 2 hydrogens over here. So that makes the hydrogens equal. But let's look at the oxygens. 2 times 2, that gives me 4, plus a 1 gives me 5. Now, I can't use 2.5 here to give me 5, which means that I have to multiply everything else by 2. Therefore, this is what I mean by trial and error, because we're looking for whole integers. So if I put a 2 now in front of that, that makes 4 carbons. So I put a 4 here, so I multiplied it by 2, basically, what I had earlier. 4 carbons here. Now let's look at the hydrogens. 2 times 2, that's 4 hydrogens. I only have 2 here, so if I put a 2 in front, that makes 4 hydrogens. And I made my oxygen even. I had it as an odd number, so I had 1 oxygen. 2 times 1 makes 2 oxygens. And then from, well, the water, but I have oxygens from CO2 as well. I have 4 times 2, that's 8 oxygens here, and 2 oxygens from the water. That makes a total of 10 oxygens on this side, but I only have 2 on this side, so to make them equal, I can put a 5 in front of the oxygen. So now 2 times 2, 4 carbons, 4 carbons. 2 times 2 hydrogens, that's 4 hydrogens, 4 hydrogens. 5 times 2 is 10 oxygens, 4 times 2 is 8, plus 2, 10 oxygens, and I am balanced. Okay, I'm running out of room, so I'm going to erase this, and then we will do the next set of these types of problems to get the hang of how to actually balance chemical reactions.